Bismillahirrahmanirrahim. So we are back with our gas chromatography topic, and today we will be dealing with detectors. It is basically detectors. So the detectors which are actually used in the gas chromatography. Fine. अब ये one of the important topics है इस लिहाज से कि इसमें आपको ज़्यादा वो it's basically like an instrumentation, and उसमें ज़्यादा some sort of more physics is involved, and then there's some complex chemistry is involved. Like at this level, so we're actually I'm preparing this topic for the UG, the BSc level. तो यहाँ पे हमारा जो exam pattern भी हमारा है वो it's like the objective type as far as your 6th semester is concerned. तो इस हिसाब से I will try to discuss it with the basics. जहाँ से हमें क्वेश्चन आएगा, and we should actually get some idea about what actually happens in these detectors which are used in the gas chromatography. Now, इसको start करने से पहले, so जैसे मैंने कहा था gas chromatography में at the end the analyte is getting eluted from the column. Let us say this is a part of that column. So this is the part of this column. यहाँ से our analytes are getting separated, and जैसे मैंने कहा था gas chromatography में, let us say these small arrows indicate our molecules which are getting separated, and these the waved arrows which actually indicate the carrier gas. So मैंने कहा था again last lecture में gas chromatography के कि we have basically here we basically have the मोबाइल फेज जो है यहाँ पे वो कैरियर गैस एक्ट करता है, और वो करता क्या, that actually carries these molecules which are in the vapor state through this column, and then through this column they're getting separated. So at the end of the column, now let's see we're actually at the end of the column. So these components are getting eluted. Let us say this is component 1. It's getting eluted. हमारा जो sample था, after passing through this tubular column, so we are getting one eluted. Along with this, carrier gas is also getting eluted. Fine. Let's say at the moment, first component, हमारे mixture में component बहुत सारे थे. Once they pass through some process through this column, finally first one is getting eluted. It's coming out of the column. Now, column से ये separate तो हो गया. What we need to detect this. जैसे हमने rest of the chromatographies में हमने discuss किया था, whether it is your paper chromatography, whether it is your liquid chromatography, whether it is your HPLC based chromatography, उसमें हमने कहा था कि you will finally get, with the help of PC, you will get a graph which is called chromatogram. अब इनको detect करना है. How can we detect this? For this setup, we have this topic that is the detector. So, और detector होता है यहाँ पे gas chromatography. It's very closer to the column. Now I'm making here to give you the imagination that, let's say detector is like a box here. So this is your detector. It's very closer to the column number 1. In the gas chromatography, the detector is placed closer to the column. जहाँ से जैसे ही जो अपना components, chemical, the vapor component, जैसे they get eluted, is in contact with this detector. So this is your detector. And this detector, in broad sense, इसमें दो हिस्से होते हैं. I'll just make it as it. जो पहला वाला जो part इसका होता है, this part is basically the sensor part. So your detector has one part, that is your sensor part. और sensor में it's a broad field. There are molecular sensors, you have pressure-based sensors, you have different types of sensors. And sensors basically करते क्या? What they do is they utilize some of the properties of the molecules, and with the help of that properties they can actually distinguish what comes out from the column. Fine. So that's in general sensor. और sensor के साथ में दूसरा part होता है वो जैसे something gets detected with the help of this sensor part, now it converts the second part, it converts this sensor response into the electrical signal. The second part hota hai, that is basically, it is for, it is a type of electrical setup where we can actually, where from we can get electrical signals. So basically, this part converts that sensor response from this part, from this sensor part into the electrical response or into electrical signals. So in general, I should say a sensor has two parts. One part that detects some of the properties of these molecules once they come in contact with this detector. And then it's in communication with the second part that converts these properties into the electrical signals. Now, once it has converted electrical signals, and then these signals from here, these signals which are alternating current based. So they are alternating signals. It's an alternating current. See, and then this setup also converts these alternating currents into digital signals. So the signals have to be digitized. Digital signals. Fine. तो finally हमारा जो data निकलता है from this column, जो हमारे molecules निकलते हैं, for example, at the moment molecule 1 is eluting from the column, once it's getting eluted, it's closer to this component, this part of this detector. So it has, now this molecule, they have some property. For example, so मैंने कहा था, अब कौन सी property, this part, this sensor will detect, you can use some of the properties, let us say the thermal conductive property of molecules, for example. ये हम बाद में भी slightly in the second part discuss करेंगे, वहाँ we'll get better understanding. For example, thermal conduction property. This sensor part can utilize this one. और इन molecules को यहाँ setup में हम लोग ionize करते हैं एक detector में, so it can use that ionization property to detect the molecules, कि molecules ज़्यादा ionize हो रहे कि कम, और अगर हमारे पास है for example 3 molecules, तो obviously they have different ionization power. We can also use the property called as the emission property. For example, atomic emission. And we can also use the property, this setup can detect the molecules with the help of a property, for example, chemiluminescence. Chemiluminescence, that's your fluorescence, phosphorescence, and later. So this is basically atomic emission, fine. So we have fluorescence, phosphorescence. So different types of properties, ये detector use करता है in order to trace the molecules. For example, molecule 1 is coming. After some time, let us see now the molecule 2 will come after 5 minutes. So we have molecule 2 coming from this column, eluting from this column. जब ये दो पहुंच जाएगा, क्योंकि उनके ये properties different होंगे, depending on which type of detector we are using, accordingly the sensor will have a response, and then it will actually transduce the signal into this electrical part, where that property will be converted to the electrical signal, and we'll get electrical current that's alternating, and then that's converted into the digital signal. So now this phenomena we call it digitization. So once we have a digital signal, and then we know our computer systems respond to this code, digital codes only, that is 0 and 1. So ultimately, we have the PC here, and that PC will give us a graph. It's basically the signal response versus the elution time, जो हमने पहले से कहा था, retention time basically. So then we'll get a graph here. So the number of peaks will give us, let us say it is 1, 2, 3. इसका time कम है, that means the one which first elutes from the column. So that's 1, 2, and 3. And then with all of this graph, we can actually get the information how many types of compounds are there, and the compounds are separated. Fine. So this is our final information. अब ये जो properties मैंने कहा कि किन properties की बुनियाद पर ये detector molecules को detect करता है, जो मैंने कहा these are some of the properties. Now वो properties को हम we can categorize them as those properties. We can categorize them as the general properties, or we can say there are some specific properties. ये स्पेसिफिक भी हो सकती है. जनरल मीन्स यहाँ एक इंपॉर्टेंट बात है, आप क्वेश्चन कर सकते हो, यहाँ से कैरियर गैस भी आ रहा है, सो दैट कैरियर गैस विल आल्सो कम इन कॉन्टैक्ट विद दिस डिटेक्टर. दैट मीन्स डिटेक्टर कैन आल्सो दीज प्रॉपर्टीज ऑफ द कैरियर गैस डिटेक्टर विल यूटिलाइज, एंड देन यू विल गेट अ पीक फॉर द डिटेक्टर आल्सो. This is the carrier gas also. Then will be in the confusion that which peak belongs to the carrier gas and which peak belongs to your chemical the compound or the component which are actually interested in the separation. उसके लिए ये है, this is the main thing, that category 1 we have general properties. General properties means those properties which are common both in carrier gas, and they can also be found in your molecules, the chemical components, which are actually the topic of interest, chemical components, जो कॉलम से निकलते हैं. तो जब वो प्रॉपर्टी जो इसमें भी हो इसमें भी, that's one way. Specific property means this is specified to the chemical components, the chemical species. पर बहुत रेयर होता है कि स्पेसिफिक केमिकल कंपाउंड की कोई ऐसी प्रॉपर्टी हो that can be utilized. But then there's a property, for example, one of the common properties which we utilize as far as the specific property is concerned, that is nitrogen to the phosphorus content. So one of the specific properties, that is nitrogen to the phosphorus content. So different molecules got different nitrogen to the phosphorus content hoga. Accordingly, we can get this graph, and it will be specific for the, जैसे मैंने कहा था प्रीवियस लेक्चर में, गैस क्रोमेटोग्राफी में जो कैरियर गैस हम यूज करते हैं, दैट इज दे आर इनर्ट गैसेस लाइक हीलियम, हाइड्रोजन, समटाइम्स नाइट्रोजन. फॉर एग्जांपल, अगर हम हीलियम हाइड्रोजन यूज करते हैं, दैट मीन्स सो देयर विल बी नो इंटरफेरेंस एट ऑल. फाइन. एंड देन इफ यू कंपेयर द जनरल प्रॉपर्टीज, अब इनसे कैसे हम डिटेक्ट करते हैं? यहाँ पे यूजुअली कैरियर गैस और केमिकल कंपाउंड्स के बीच में, फॉर एग्जांपल, इनमें से कोई प्रॉपर्टी जो हम यूज करें फॉर डिटेक्शन, इसमें वैल्यू ऑफ दैट प्रॉपर्टी वेरी हाई as far as chemical compound is concerned. For example, if we say thermal conduction, so thermal conduction molecules will be different and carrier gas will be different. Since its magnitude different hoga, we see that the degree of that particular property will be more in the chemical compound, less in the carrier gas. So with the help of that also, we can get a response which is actually that response belongs to the chemical compounds. So this is in general a brief overview, a basics of the detector systems in the gas chromatography. अब हमारे पास based on कौन सा property हम use करें, how actually we are having the detectors, we can have many types of detectors. For example, we can have one detector that is mass spectrometry based, MS based detector. That's mass spectrometry. Second type of detector we may have, जो हम use करते हैं, that is flame ionization detector. Flame ionization detector. मैं इसको अभी अंडरस्टैंडिंग यहाँ पे खोल नहीं रहा हूँ. I'm not making them to get inside this mass spectrometry, inside FID. We'll see this later. We'll choose some basics, some main component, then we'll discuss those in the next class. Third one, we can have thermal conductivity based detector. We can also have the electron capture detector. And then fifth one, atomic emission detector, or chemiluminescence type of detector. Chemiluminescence, that is C, that is your CS, you can use formula. And then one more we can have, that's photoionization. You have flame ionization here, there's some flame involved, and here's some light involved. Photoionization detector. तो ये हमारे डिटेक्टर्स होते हैं जो हम यूजुअली करते हैं, डिपेंडिंग ऑन विच टाइप ऑफ प्रॉपर्टी दे विल यूज टू डिटेक्ट दैट. फाइन. तो इनमें हर किसी की अपनी अपनी एप्लीकेशन होती है. दे मे नॉट बी एप्लीकेबल, फॉर एग्जांपल, दिस मे नॉट बी एप्लीकेबल टू ऑल सैंपल्स. इट मे बी एप्लीकेबल टू एरियल सैंपल्स, इट मे बी एप्लीकेबल टू जियो सैंपल्स, इट मे बी एप्लीकेबल टू द फूड सैंपल्स. तो समटाइम्स सम ऑफ द डिटेक्टर मे बी एप्लीकेबल टू द ऑल सैंपल्स. तो इनकी एप्लीकेशन भी वेरी करती है. फाइन. सेकंड, उनका जो इंपॉर्टेंट कंपोनेंट होता है डिटेक्टर में, जो यहां डिस्कस करना चाहता हूं, दैट इज डिटेक्शन लिमिट. डिटेक्शन लिमिट एनालिटिकल केमिस्ट्री में हम लोग जनरल यहां पे मैं एक्सप्लेन करूंगा एलडी. दैट मीन्स कि मिनिमम क्वांटिटी एक डिटेक्टर कितना डिटेक्ट कर सकता है. फॉर एग्जांपल, अगर हमारा जो सैंपल था, जैसे मैंने यहां कहा, लेट अस से इट हैज 3 कंपोनेंट्स, सो वी हैव 1, 2 एंड 3. इनको हमें सेपरेट करना था और डिटेक्ट करना था. इसमें एक की 1, जैसे 3 जो है या 1, उसकी कंसंट्रेशन बहुत कम है. When concentration of component 1 is low, that means when it passes through the column, इसकी बहुत minute concentration. When it comes in contact with the detector, क्या डिटेक्टर में इतना पावर है, it will detect that minute response also. So that's basically, it has something to do with the detection limit. How much minimum quantity of analyte a detector can detect. So usually ये जो detectors है, they are quite advanced. They usually detect usually. We'll discuss that. जो भी इनमें कुछ important होगा वो हम separately next class में detect करेंगे. But here usually उनका response, they are safe in the microgram level. That means अगर आपका analyte जो है, it is the concentration of 10 to the power minus 6 grams. The detector can have the response. We'll get the graph for that. Fine. And उनमें कुछ detectors है, they can even show the response at the picogram level. Fine. Some can show at the femtogram level. That means picogram means when your concentration is very very less, around minus 12 grams. And femto means it is 10 to the power 15 grams. तो इस range में, that means they have enough response to be the suitable for the detection. अब detection detectors के लिए last point जो यहाँ पे I want to bring into your attention that if you want to have an ideal detector, ideal detectors के लिए ये property होनी चाहिए. Number one, it is detection limit should be low. It's a low detection limit. At least it should not be above this, and it should be from this to 10 to the power minus 15. जैसे मैंने कहा, and almost they have this property. They can actually, the character, they can go in this range. तो micro से नीचे means it's not suitable. Fine. Second thing, let us say हमने एक बार इस sample को यहाँ से, एक sample से यहाँ से pass किया, we got this graph. Can we reproduce the same results again and again? We know in the statistics, जिसमें analytical chemistry में पढ़ती हैं, अगर हमने एक sample को 2-3 times separate किया, every time we got similar results, we say our data is correct. So your detector, you should give us the reproducible response. Reproducible response. And third point, जो कि modern इंस्ट्रूमेंटेशन होता है कि जितना एक इंस्ट्रूमेंट इजी हैंडल करना होगा, दैट बिकम्स मोर बेनिफिशियल. उसमें कॉस्ट भी कम हो जाता है एनालिसिस का. नहीं, आपने एक सैंपल को एनालाइज करना, अगर आप में ज्यादा एक्सपर्टाइज की जरूरत नहीं है और बहुत कम टाइम में चीजें हो जाती है, वी से दिस इज आल्सो बेनिफिशियल. सो वी से दैट इट शुड बी इट शुड बी इजी टू हैंडल या easy to use or easy to deal with. That means you don't require that much expertise. So actually you are excluding it from the expertise. So these are some of the basics for an ideal detector. तो ये हमारा important class था detector के हिसाब से. अब इसमें कुछ important detectors है. For example, you have this mass spectrometer detector, बहुत important है और syllabus में भी है. Likely your flame ionization important, likely your electron capture. तो ये we'll discuss them inshallah in the next class. Till then, this is, I believe it will be enough information here, even enough information for any competitive exam. If you have any question, please go back. You can actually write me here again and again. मैं आपको बोल रहा हूँ कि please write down me your number also. You can use that at gmail.com.